The next hint is to combine these two fractions together into one fraction. Can I add these two fractions together as they are right now? No, they're unlike denominators. So what would be my common denominator that I would have to add them together? What would be my LCD, my least common denominator? And I had a student last hour too that wanted to do this. Could I do that? No, because of what this is right here, the plus symbol. So you cannot cancel those right away unless this was a multiplication. It's not. So just give you a heads up on that. So what's LCD? What's the least common denominator for, you have to take both pieces with it? All right, so in the first fraction, the sine of theta over 1 plus the cosine of theta, what am I missing from its least common denominator? What don't I have? The sine of theta. So I have to multiply that numerator and the denominator by what I'm missing from the LCD. So I multiply both pieces by the sine of theta. Now in the second fraction, what am I missing from its LCD? What do I need to multiply by? The 1 plus cosine of theta? Now are the two denominators exactly alike? Yes. So I can combine the two fractions into one single fraction. So I add the numerators and keep the denominator. So I have sine of theta times sine of theta plus cosine of theta, 1 plus cosine of theta, all over my LCD. Now let's do some cleanup. Let's clean up that numerator. The sine of theta times the sine of theta is what? Sine of theta times sine of theta is sine squared of theta. Now I'm going to clean up this piece over here. So I'm going to distribute that cosine of theta through to the parentheses. So cosine of theta times 1 is cosine of theta. Cosine of theta times cosine of theta is cosine squared of theta all over that same LCD. And I'm purposely not doing any multiplication of that denominator because I'm hoping, it's lost my board connection, I'm hoping that one of those pieces in the denominator might cancel out. That's why I'm not multiplying the denominator. So you see anything yet with your identities now? What do you see? Very good. I'm going to group these two terms together. Sine squared of theta plus cosine squared of theta together. And then I'm going to keep this cosine of theta over here on the right. This piece right here is from one of the Pythagorean identities. That says the sine squared of theta plus cosine squared of theta equals 1. So I can replace that entire circled piece with 1. How does that now benefit me in my problem. What can I do next? Does that get me to cancel out a big chunk? Yep. Now I can cancel out this entire factor of 1 plus cosine of theta and 1 plus cosine of theta. I'm left with 1 over the sine of theta, which is cosecant of theta. In its reduced form. Last example. On your own, see if you can try this one. I'll give you about maybe a minute and a half lead time. See if you can kind of look around, see the identities, some of the practice, and see what you might want to do to get started on it. All right, tell me what you did. Where'd you start? What did you do? Okay, you factored out a cosine squared of x. You took out the GCF. Cosine squared of x. So what are you left with? Good, 1 plus tangent squared of x. Then where did you go? Very good. Recognize that this piece right here is one of the Pythagorean identities, which can be replaced. 1 plus tangent squared of x is secant squared of x. Yep. Then where'd you go? Reciprocal identity, good. Secant squared of x is written as a reciprocal to cosine. Then what? Cancels out, that's the best part. Then you get things to cancel out. So your final answer is 1. I think we'll skip this one and go on to your assignment. It's a pretty big assignment. There's a lot of practice. This is a challenging chapter, so you're going to see bigger homework assignments now. Use your friends to help you out if you get stuck. Ask me for help. But there's your assignment.